Hi everybody, in this video we are going to be talking about Unit 9.3.1, the Associative, Commutative, and Distributive laws. So you want to be on those pages of your notes so that we can be taking some notes together on that topic. So one second, and I'm going to share my screen with you so we can go through that together. All right, so we should have that topic in front of you. Let me kind of move things around so I can see a little bit better. All right, so for this first topic of Unit 9.3.1, this one's not actually located in your EdReady study path. We needed it to be in there because it has some really important definitions and terms, but you won't have any EdReady problems like the practice review, check your knowledge on this one. We're just taking notes on it so we have this terminology. All right, so for the first one, it's going to be mathematical term. And it's going to be a number or a variable or numbers or variables that are multiplied together. I'm sorry, it's a little bit hard to write with a stylus and an iPad, but that says the word multiplied. So multiplied together. Terms are separated by mathematical operations. So that could be something like, maybe we've got like -1/2 x squared plus 4x minus 3. And each of those are going to be mathematical terms. So like if I said, what's the coefficient of the x term? So you would look through and say, well, where's the x term? Not the x squared term, but the x term. And you would say 4. Excuse me. Or if I said, what's your constant term? That's me talking about a specific mathematical term. And you would say -3. That's your constant term. And so this is a mathematical expression that is made up of 3 terms. So that might be something that you're jotting down, right? So that mathematical expression right there, it's actually called a trinomial, is made up of 3 mathematical terms. And so I'm just going to write that in. Then we've got a variable, which can be a letter or symbol used to represent a quantity that can change. We use X and Y most commonly, but any letter can be used. So that might be something like area equals 1/2 base times height. We could have something like -3x plus 2. And so in the first one's an equation, the second one's an expression. But in this equation, we've got our variables of base and height, and then we've got a variable of an a. I'm hoping you might remember the terms too, independent and dependent variables. So in this example, our base and height would be our independent variables. So they are independent of one another, and they're independent of, like what the area is going to be, because the area would be considered your dependent variable. So the area calculation depends on what the base and the height of your triangle would be, right? And the next one, of course, our x is going to be our variable. A constant is unlike a variable, and a constant term is a quantity that does not change, which is why it's called a constant, right? Like that makes sense. So, we could use the same one where area equals 1/2 base times height. You're going to have the 1/2 in there. In this one, we're going to have -3x plus 2, and you'd have the -3, and you'd have the 2. So no matter what in this expression, in this equation, that 1/2 is going to remain constant. Same thing with that -3 and 2 on the next part. Some of you at this point might be saying, no, wait a second. I thought you just called -3 a coefficient instead of a constant. Well, you're right. That's because it's coming, right? So a coefficient, you see it in the very next term. It's a type of constant term. So it even gets more specific. So it's a very special type of constant term that is going to be multiplied by a variable. So you can think of it almost like a Venn diagram, like you have, here's our constants, and then inside of it would be coefficients. And so are all constants considered coefficients? No. But are all coefficients considered constants? Yes. And so a coefficient just becomes a smaller basket, and it's a type of constant term. So even if we just kind of keep on with this, area equals 1/2 base times height, the 1/2 would be considered a coefficient. And if we went -3x plus 2, the -3 would be considered a coefficient for that. Then our next two terms, expression and equation, they kind of bounce off of each other, or not bounce off of each other, but they're the two that you're going to want to compare and say, okay, they're similar, but how are they different? So an expression is a mathematical phrase that is made up of operations, numbers, and or variables, but it does not contain an equal sign. So kind of following down the examples that we have up above, it would be the -3x plus 2. Or we could have something like ab squared plus 4a squared b minus 3ab. And then that's just an expression. So there's no equal sign in that. For our next one where it says a mathematical statement, so instead of a phrase, we call it a statement. And it's made up of operations, numbers, and or variables, and an equal sign. So that's your big distinction. One has an equal sign, one doesn't. So this one, we could say area equals 1/2 base times height. We could also say -3x plus 2 equals -15, something like that. And the other thing that I would say, just to kind of keep in mind, is that for an expression, the directions for an expression are typically simplify. So it'll say simplify the expression, and for an equation, it'll say solve. And so simplify just means we're combining like terms, which is our next term we're going to talk about. And solve means we're actually solving for that variable. So we would, like on this example here, we would subtract the 2 from both sides, and then we would divide everything by -3. And that's how we'd solve for that one. On the expression for simplifying, we actually can't simplify this anymore because it's already been simplified. If I did something like we added 4x to that one, like if that was the expression, then we could simplify it. And we would say, well, what's -3x plus 4x? And it would be x, and then it'd be x plus 2 for us to simplify it. All right, so to talk about the next one of our like terms. So like terms are terms that have the same variables and exponents. They can be combined together. They do not need the same coefficients. In order to be considered like terms. So they do not need the same coefficients, but they do have to have the same exact variables raised to the same exact power in order to be considered like terms. So to give you just some examples on that. So for example, let me look at some of the ones I wrote down. Like if I said xy and yx, and I said, are those like terms? I would hope that you would say yes, because you're looking, do each of them have the same exact variables? When you should look, is there an x in both of them? Yes. Are both those x's raised to the first power? Yes. how about the y's? And it's the same story. And what happens is that you could actually just use the commutative property, right, to change those around. You'd have x and xy, and you would say, well, what if I'm going to combine them? Well, we'd really need an operation here. Let's say it was a plus sign. So if we had this, how many xy terms do we have? We've got 2 of them. So that would be how we combined it. If we were given this one, where it gave us a plus sign to begin with. Another example in here, we could have, I'm going to change colors. We could have 3ab squared c and b squared negative 2ac. So I know you might be looking at that and saying, wait, how can that be like terms? Again, look at the variables, look at the exponents on those variables. So there's an a. Is there an a to the first power in this one? Yes. Is there a b squared in both of them? Yes. Is there a c to the first power in both of them? Yes. And the coefficients don't matter. So if I just was asking the question, could these be considered like terms? Yes, they can. And you can even rewrite the one on the right so that it's in alpha descending order is what that's called. So you put the number up front, the coefficient, and then you put the variables in alphabetical descending order. Non-examples. So a non-example of like terms, this happens a lot. The one I'm going to give you here in a second is the 2 plus x. Oftentimes students will tell me that equals 2x. That is not true. So 2 plus x does not equal 2x because look at the 2. It's just a constant term. It doesn't have an x on it. So you can't combine those. Another one that gets confused in here is 2x and 2x squared and 2xy. So looking at all of those, sometimes students look at the 2 and are like, oh, they all have a 2 up front, so I can combine them. You can't because none of them have the same exact variables raised to the same power. So that's why they're not considered like terms. All right, let me flip my page here. So our rules or conventions for writing mathematical expressions, we are going to put the coefficients before the variables. So we're going to put the coefficients before the variables. Examples of that would be like, we're going to do 10x, not x10. We would also do something like 5x, not, oh, I'm sorry, that need to be a negative 5x, not x times a negative 5, because that just looks weird. It also kind of looks like, you know, like somebody might misinterpret that to be x minus 5. Another one that you might see is we would write 5xy, not x 5y. So you want to put the number all the way to the left and make it look like the coefficient. Because it is a coefficient. All right, so then we're gonna, we have special cases in here too, and we typically write 1x as just x. Is it wrong for you to write it as 1x? No, it's not wrong for you to write it as 1x, but you don't need to, you can just write it as x. Thing we usually leave out 0x because it's the same as 0. So on this one, we typically don't write it as 0x because 0 times any number is going to be 0. So you can just leave it at 0. Then we write variables in alphabetical and in descending order. Another way you can say it, you just have to be careful with the emphasis, that you can also write variables in descending alphabetical order, meaning you're putting them in alphabetical order, but then you're putting them in the descending order based upon their alphabetical arrangement. Okay, so let's look at some examples. So some examples we might have, let me just kind of mix some of these up. All right, so one, we would have like 5x squared plus 2x minus 3y cubed plus 2y squared plus 4. And just looking at that one, so this one's already in alpha descending order. So alphabetically, we're putting all of the x's up front, then we put all of the y's, and then we put the constant term at the end. And in the x's, we put it in descending order. And in descending order, we're putting the x squared first, then the x, then we did the y cubed, then the y squared, and then the constant term. Another one we might have is 5x cubed plus 3x squared y to the 4th minus x y squared z minus yz. And again, looking at that one, alphabetical and then descending order. Alphabetically, if there's like, think about in a filing cabinet. So you're going through the files, what's going to come first, an x term or an xy term? And I'm talking about this. So an x to the 3rd term or an x squared y to the 4th, which one alphabetically comes first? Well, it's going to be just the x term by itself. So we're going to, put 5x cubed, and then looking at your next terms, alphabetically, the xy term would come before the xyz term. And then that yz term is going to come at the very end because it doesn't have an x on it. So alphabetically, it comes last. And then another one, we've got x squared plus x squared y plus y squared z plus yz. And again, alpha descending order. This is one that can sometimes confuse people because they're like, wait, why is that x here instead of right here? So this is going by the hard, fast rule of you put everything alphabetically first, and then it goes by descending order. It's not going to be counted wrong if you put the x behind the x squared y. If we all are writing it and using the same conventions, then our answers actually match up. And so that's why. And so the same thing here, I want you to kind of look at this example part of it, or this part of the example, and make sure you're understanding, why the y is coming here. And again, it's because the alphabetical order trumps the descending order part. So you're putting the alpha, the y to the 1st power by itself, because the yz term over here would come next alphabetically. All right, so let's try some examples. So if we had number 1, we would have b 10a plus 6b squared minus 4a squared b minus 0ba plus b. So I want you to get that written down. And then you should pause the video and see if you can figure it out on your own first. So pause the video, see if you can figure it out, and then I'm going to walk you through it too. So the first step I would do is to go through every single term and put it in the correct order. So like this first term, I'm looking at it and we need to fix it. We need to put our coefficient up front. We need to put the variables in alphabetical order. So it's going to be 10ab plus 6b squared, because that second term's fine. And then I'd look at the next one. That next term also looks fine. And then that minus 0ba, it's going to go away because 0 times anything is going to be 0, right? So that goes away to 0. And then this is going to be plus b. So then what I would do is I would look through all of my terms and say, alphabetically, who's going to first? It's going to be this one or it's going to be that one. And as far as the letters that they each contain, they contain an A and a B, right? So then you look at the descending order part. So I'm looking at the A here and the A here. The A over here for a squared higher power on that A. So the term is going to come, and I'm going to have negative 4A squared B. And then I'm going to add the 10AB, and then some 2 terms. And then I'm looking at these. This one has the higher power, so that one's going to come next. And then I'm going to finish off class B. Then I'm going to write plus 6b squared plus b. And then I'm going to circle my answer or box it because we're done. That's our final answer. We can't combine anything. So sometimes I get the question of, well, wait, can't we combine these? No, they're not like terms. They have the same exact variables, but they are not raised to the same exact power. So you cannot combine those. So for our next one, I want to try b squared times -4 plus 1a squared minus 2ba plus 3ab minus, I'm going to have to write small, b squared times a -a times a 4. So again, I urge you to pause the video and try it out on your own first and see how your answer compares. And then just kind of fast forward to check the answer and see if you did it right. If you didn't, go back and watch the process. So here I'm going to go through each of these terms and put them in the correct order. For this next one, I'm just going to write a squared. We don't need to write the 1 times a squared minus 2ab plus 3ab. And then we've got a negative times another negative, so it's going to be a positive 4ab squared. All right, so now I'm looking through the terms and I'm looking for which one alphabetically is going to come first. And that is going to be this one right here. So we're going to have a squared, and I'm going to cross it off because I'm done with it. And then I've got an ab squared down here. So I'm going to write plus 4ab squared. I'm looking at these two and I can combine them because they're the same exact variables raised to the same exact power. So we're going to combine those at plus ab. And then finally, we're going to write minus 4b squared. And that is going to be our answer. So I'm going to box that up. I am going to try another example. I'm trying to figure out where I'm going to squeeze it in though. I'm going to put it in right here. All right. So the next one I've got is going to be -2x. So this is my example 3. -2x minus 3 times the quantity of 5x plus 4x minus 2. So on this one, again, pause it and see if you can figure it out and see if your answer is going to be the same as mine. So what I would do is take this -2x and we're going to have a -3. I want to look inside my parentheses first and combine any like terms that I might have. And now I am ready. So I'm looking at a negative, and that's mine. Here's multiplication. So I want to go ahead and distribute. And then we're going to have -2x minus 27x plus 6. And now we're ready to combine. And so we've got -29x plus 6. And that should be our final answer. One more I'm going to write down for you, and I'm going to give you the answer. I'm going to see if you can do this one on your own. So we've got 1/4 times the quantity of x minus 9x. And then we've got minus 25 times the quantity of x minus 1/5. So again, on this one, I would look at it, see what you think. I would look inside the parentheses, see if there's anything you can combine first. And I think I have space, so I'm just going to do this one. So if we've got 1/4 and we've got x minus 9x, that's going to give us -8x. And then on the next part, I can't combine anything in that set of parentheses, x minus 1/5. So I'm going to go ahead and distribute. And then we've got minus 25x. And then think about when we're multiplying, we're going to be doing -25 over 1 times a -1/5. So your 5s are going to cancel here. Negative times a negative is going to give you a positive, and so it's going to be 5 in there. And then here too, for our next part, we're doing 1/4 times a -8. It's like, well, what is 1/4 of -8? It's going to be -2, right? So -2x, and then we've got -25x plus 5. Now you're ready to combine these two, and we've got -27x plus 5. And so that gives you your last example there. And that is it for that topic. And so if you have any questions on it, please feel free. Make sure you're texting or you're emailing or you're asking me in office hours or in class. Just make sure you're reaching out to get some help. Thanks for tuning in.